Hello! Okay, so the purpose of this video is to show you how domain and range works. Okay, so domain represents the possible x values. Range represents the possible y values. Okay, this concept is very Algebra 1. If you guys can kind of see a pattern here, this is very easy. Okay, let's try to look at an example. Okay, let's say we have this parabola here. So this is the shape of a parabola, and I wanted you to tell me what the domain and range of this function is. Okay, so first let's look at which x values exist. Okay, so if I were to just look at, so you see the cursor here, just follow where I have on the cursor. Okay, so what we have is this graph goes all the way. It starts at -1 for the x's, and it goes all the way until 4. So if we were to write this inequality, the way that we can represent the domain would be like something like -1 is less than or equal to x, and then is less than 4. The reason why it's less than 4 is because we have an open circle here. Okay? If we want to represent the range of this function, in order to represent the range, what we want to do is instead, range is going to be the y values. So if I were to, so follow my cursor here. You see the cursor? Okay, so what this means is if I go all the way down, if I go 0, -1, -2, -3, so that means it includes -3, and then it goes all the way up, up. But then it doesn't include 6 because we have the open circle. So that means if we were to represent the range, it would go from y values between -3 and 6. In other words, -3 is less than or equal to y is less than 6. Okay? And that's basically what we have there. Okay? So that's the first type of example. Okay? Now, what we have is we have an absolute value. So remember we went over previously, we went over absolute values, the one with the 2 lines and the x in the middle, that is absolute value. If you were to graph it, you're gonna get something that looks like this. Okay, let's say I ask you to tell me the domain and range of this function. Okay, so again, domain is x's, range is y's. Okay, so let's look at the x's. Okay, so if we look at these x's here, let's say I were to just kind of trace, as you can see here on the x's. So this means the x is going to go all the way until -1, -2, -3. So it doesn't include -3. But it goes all the way here, and it includes 7. So if we were to represent the domain, it would be start at -3 is less than x, and then less than or equal to 7. Okay? So that would be the domain. In order to determine the range, okay? So the range of this function, so now we look at the y's. So you see, follow my cursor. You follow my cursor here? So what we're doing is we're looking at the y's that exist. Okay? So that means we go from, it looks like 2. Okay, so it's going to include 2. So 2 is less than or equal to y, and then less than or equal to 6, 7, 8. So we're going from 2 to 8. And there we go. So that is what our domain and range looks like for this. Okay. One interesting thing I also want to mention is that some of you might wonder, if you look at the y, you're wondering why is y equals 6 included? So you see here, it's excluded. We have an open circle at -3, 6. But what we can see here is that the function is still continuous at this point, which is 5, 6. Okay, so since this point exists compared to what we have here, the range will still consist of these values that are between 2 and 8. It includes 2. Oh, that's a typo. Wonder if I can change that. I think I messed that up. Sorry about that. Let's go ahead and change that. That should be, yeah, that should look like that. Okay. So forgive me with the, there we go, and there we go. Okay, so that's what it should look like. I apologize for that error. Okay. Right, so let's look at another example. Okay, let's look at a function with a degree higher than 2. Okay, So something like, so if you see something like this would be something, it could be a odd function if it, if this comes all the way down and this comes up. It could even be an even function if this comes down and then this goes back down. Okay, but that would be some sort of function with a degree higher than 2. So in order to define what the domain and range of this function is, so we need to look at our x's, right? So if you look at our x's here, so let's go ahead and trace. If you kind of see a little pattern here, this means that our x's have to go from -5 to 6. So, but it's not going to include -5 or 6. So it's -5 is less, -5 is less than x is less than 6. Okay? Our range in this case is going to be interesting. So our range, it's going to come all the way down here. So our range is going to consist of all these values here. Okay? So it's going to go from -6 all the way to 3. So -6 less than or equal to y is less than or equal to 3. Okay? And it's actually going to be continuous at these certain y values that you see here and here, because, well, the open circle, there's open circles, but then there's, it's still continuous there. So, yeah, so that the range won't be affected. So let's see. There we go. Yep. So -5 less than x less than 6. And the range is going to go from -6 less than or equal to y less than or equal to 3. Okay, let's look at another example. All right, the rational function. Okay, this one's a fun one. What I did was I want to help you guys out with this. This one is a little bit interesting to kind of think about. Okay, so what we have is, if you want to identify the domain and range of this, so if you want to find the domain, as you can see here, I'm just going to trace this for you. This means that the graph, this graph here, our rational function, something like 1 over x or 3 over x, or, like that kind of thing, something of this nature is not going to pass this line. This invisible line is called an asymptote. Okay? Some of you may learn this in maybe pre-calculus, if you guys, or even calculus if you decide to go that far. But this is an example of an asymptote. In this case, this is a vertical asymptote. Okay? And then actually, so this is also an asymptote. So that means the graph cannot go past that line too. But we'll discuss that one later. Okay? But anyway, what this means is that for this particular function, x cannot equal 2. Okay? So that's one way that we can express that. X cannot equal 2. If we were to trace this here, so you see what we have right here? This means that y can't equal 4. Okay? Based on what we have, y can't equal 4. So if this is another asymptote, and actually if you guys decide to learn this in pre-calculus or whatever, this is called a vertical asymptote, and actually this is called a horizontal asymptote. Okay, but that just says what x and y cannot equal. So if I go back to the slide here, in order to understand what this notation means, so this says the set of all x's, or in other words, the set of all real numbers such that x can't equal 2. Okay, and then this one says the set of all y values, so the set of all real numbers for y's such that y can't equal 4. Okay, so this one is an interesting case. Okay, let's look at another example, just so you can kind of see a pattern. Okay, so let's say I give you this, and I ask you to tell me what the domain and range of this function is. Okay, so similarly, let's go ahead and graph. And just so you can see here, so if I were to just kind of draw like a little invisible line, we have a nice little invisible line here. So as you can see here, this means x can't equal -3. So -1, -2, -3. X can't equal -3. Similarly, if we were to look at what we have here, so you see this here, this means that y can't equal -1. Okay, so those are our two restrictions for this one, if that makes sense. Okay, so this notation again, this means the set of all x's, so that set of all real numbers are for x's such that, so that line means such that x can't equal -3. Okay, and this for the range here, so this means the set of all y values such that, so set of all real numbers that are y's, such that y can't equal -1. Okay, so that's generally how that one works. Okay, right, we're going to do a few more, but I'm just going to stop the video, and I'll see you in the next one. See you later. Okay, bye. Hello. All right, so let's keep going. Okay, so let's say I asked you to tell me the domain and range of this particular function. Okay, so let's look at the x values. So you see this arrow, this means, as you can see here, it's going on forever and ever in x. And also this way, it's going forever, ever in the x this way. So as you can see, what this implies is that x just continues forever in negative or positive direction without a restriction. So that means the way that we can represent the domain would be the x's consist of all real numbers. In other words, we can represent that with a negative infinity and a positive infinity. So that means x is going to approach negative infinity and x is also going to approach positive infinity. Or in other words, all real numbers. That would be the domain. The range in this case, so if we look at the range here, so it looks like if you come down here, the range can't go past -4. So if you look at the y values, it has to include everything that's above -4. Okay, so the y values in this case are going to be greater than or equal to -4. Okay, and that's exactly what we have there. Okay, let's look at another example. Okay, domain and range of this function. Now, this is where it gets a little bit interesting. So, as you can see, these arrows mean we're going forever and ever in a certain direction. So this means there's no restrictions on the y's. You see that? There's no restrictions on the y's. It looks like they might approach something, but there actually is no restriction on the y's. They keep going forever this way and forever this way. So this means the y values are going to approach a negative number, and the y values here are going to approach a positive number. So there's no restrictions on the y's, so that's the range. Oh, I forgot about the domain. So let's talk about the domain. Okay, so look at the domain here. So as you can see, this x value, we can't go past 4. So since we can't go past 4, this means the domain is going to be something like x is less than or equal to 4, right? So it's going to be everything this way. But then the y values, there's no restriction. That's what I meant earlier. So the y value is going to consist of all real numbers. In other words, negative infinity is less than y is less than infinity. Something like that. Yep. One thing I also wanted to mention is some of you might be wondering why is there no equal sign underneath the infinity? And that is actually a very, very valid question. Okay, so the reason why is, well, infinity doesn't have a restriction. It's just kind of, it's just known as a really, in the positive direction, it's known as a really big number, right? So there's no restriction. So that's why it has to be, anytime you use infinity, it has to be some sort of less than symbol. Or you know, like you see here, you won't have an equal sign underneath. Okay, let's look at the next example. This is an example of a line. Okay, some of you may have heard of lines before, but in order to tell me what the domain and range of this function is, okay, so as you can see here, what we have is for the x's, so we look from here to here. If we look at the x values, well, it doesn't include -1, but there's no restrictions as x is really positive. So in this case, this means x just has to be greater than -1. Okay? But if you look down here for the range is going to consist of all values that are going to be below, it looks like -2. So what we have in this case, so the range is going to be all y values that are going to be less than -2. There we go. Yeah, so that's what that looks like. Okay, let's look at another example. All right, so can you tell me what the domain and range of this function is? Okay, let's look at what we have here. So if you look at this line very carefully, if you look, are there any restrictions on the x's? Are there any restrictions on the y's? The x's are going to go forever this way and this way as well. So that means the domain of the x's is just going to consist of all real numbers. If we look at the y's, there's no restrictions on the y's either. So that means the y's are also going to consist of all real numbers. So in other words, the domain and the range in this case both consist of something like negative infinity, less than x, less than infinity, and negative infinity is less than y, less than infinity. And there we go. Okay, let's look at another example. Okay, this is the example of a square root. So if it's not a closed interval, something that looks like this, if you see like an arrow here, that would be an example of if you graphed a square root function. So you know, like the radicals. Remember the radicals that we went over earlier? We had to solve those. So if you had to tell me the domain and range of this, what we're looking at is just looking at the x's. So the x's for a domain, in this case, would go from 2 to 11, it looks like. So 2 less than or equal to x less than or equal to 11. And the range is just going to go from here. So range just goes from, it looks like 0 less than or equal to x and less than or equal to 3. There we go. Okay, so that's what we have there. Okay, all right. This is something that we're going to cover anyway, but I might as well give you exposure. Okay, this is an example of an exponential function. You know, like the coronavirus, COVID-19, that thing that we're in right now. Cases growing exponentially. That something of this nature is an example of an exponential function. Okay, let's say I ask you the domain and range of this. So the domain in this case, so this means we start at negative 5 here. So it's not going to include negative 5 because we have open circle. So if we go from here all the way out, so this means the domain is going to be all x values that are going to be greater than negative 5. X values greater than negative 5. If we want to consider the range, if you look at the range here, it doesn't go past 0. It doesn't go past 0. It's everything above 0. So it's going to just be y is greater than 0. There we go. Yep. So there we go. That looks like what we have. Let's look at another example. You tell me what the domain and range of this function is. So what we have is, if we look at the x's, x is domain. So this means we go from, we have open circle at negative 1. So negative 1 to 5. So it's going to be negative 1 less than x less than or equal to 5. Okay? The range is just going to be from here to here. So the range is going to go from 0 less than y less, sorry, 0 less than or equal to y and less than 3. Okay? There we go. So that's what that looks like. Okay? So that's your exponential function. Let's look at a few more. The circle. All right, so let's look at a circle. Let's say I want to figure out what the domain and range of this function is. So domain is the x's. So we can see here, domain is going to go just from negative 2 to positive 2. So negative 2 less than or equal to x less than or equal to 2. And then we have the y values. So negative 2 less than or equal to y less than or equal to 2. Yep, so that's domain and that's range for you. All right, is that the end of the slideshow? That is the end of the slideshow. Oh, awesome. Okay, in the next video, I'm going to talk about how to find the domain of a square root. And I'll see you later. Okay, bye-bye. Hello. All right, so in this video, I'm going to show you how to find the domain of a square root. Okay, so let's say we want to find the domain of each of these functions. Okay, this is also very easy. Okay, so what we can do with this, as you can see, is we have a square root. So recall that the inside of a square root here, this inside of a square root has to be greater or equal to 0, right? Because square root of 0 is going to be 0, or anything that's greater than 0 as well is going to be true. Okay? Anything that's less than will fall out of the domain. So that means x cannot exist. We're going to have something imaginary, right? So in order to find the domain of a square root, very easy. So all we need to do is we set the inside here, and we need to set that x plus 5 is greater than or equal to 0. And all we do for this is we want to solve for x. You know, it still amazes me that some of you still can't do this. But anyway, we just cancel. So this is x is greater than or equal to 0 minus 5 is going to be negative 5. Okay, that's the first one. Okay, now what we have, we want to do this one. So we want to find the domain of this function. So what we have is this is 2x plus 8 is greater than or equal to 0. Okay, so what we want to do is we want to get x by itself. Subtract 8. So we have 2x is greater than or equal to 0 minus 8 is going to be negative 8. Divide by 2 on both sides, so this cancels. X is greater than or equal to negative 8 divided by 2 is going to be negative 4. Okay, and there we go. So that's how you can find the domain of these functions. Okay, I have 2 more examples, and I'll close up, and we're done. Okay, so I'm going to go ahead and just erase. Okay, next, last 2 look like this. Y equals the square root of negative 3x plus 6. And the last one is y equals the square root of negative 5x plus 45. All right, here we go. Okay, so in order to find the domain of the functions that we have here, this says, well, we need to set the inside of this greater than or equal to 0. Okay, so now we just solved the inequality. We can subtract 6. So this is negative 3x is greater than or equal to 0 minus 6 is going to be negative 6. And then we need to divide by negative 3. So recall what we went over inequalities before, right? So anytime you divide by a negative, guess what we got to do with this sign? We got to flip it. We got to flip it. So we're going to flip it. X is less than or equal to negative 6 divided by negative 3 is going to be positive 2. Okay, so there we go. Now we need to look at this one. Same idea. We need to set the inside of this. So this is negative 5x plus 45 is greater than or equal to 0. Okay, now we need to get x by itself. So same idea. Subtract 45 both sides. Negative 5x is greater than or equal to 0 minus 45 is negative 45. And then what we want to do is we want to get x by itself. So we're going to divide by negative 5. When we divide by negative 5 here, well, this is going to cancel. And again, that's you see this inequality sign? We're going to flip it. We're going to flip it again because we're dividing by negative. Okay, so negative 45 divided by negative 5 is going to be positive 9. And there we go. So these are the x values that would make this true. If you choose x values outside the boundary, that's where you get imaginary answers. Okay, and that is it. Okay, please let me know if you have any questions on this. All right, bye.